So let's take a look at this Lewis structure. So this is ClF4 positive. First thing I'm going to do is count the number of valence electrons I have to work with. I have one chlorine, excuse me. I got 4 fluorines. So these are halogens that both have 7 valence electrons apiece. So I got 7 plus 28. I got 35 electrons to work with. Now what happens is I got a positive, which means now I've lost one of those electrons. So got a positive, minus 1, so I got 34 electrons total. These are my valence electrons. These are the ones I'm going to use for bonding and non-bonding. So a couple of things. We've got to determine the central atom. Normally the central atom is the one by itself. So in this case, it's going to be chlorine. So let's put chlorine in the middle. And then we're going to draw single bonds around the fluorine. So I'm going to kind of draw it like this. And then so what I like to do, draw single bonds around the terminal atoms, and then what I'm going to do is draw 6 electrons on each one. And then I'm going to count up how many electrons I've used up so far. So 6, 12, 18, 24. So minus 24 electrons. I got 4 bonds. Each one contains 2 electrons. So 4 times 2, that's going to be 8 electrons. So I count up what I've done. 34 minus 24 minus 8. So now I have 2 electrons left over. So again, count these up. Count the number of bonds. Each one contains 2 electrons. You can count the non-bond pair of electrons. That's 28 plus 24 plus 8 is 32 electrons. I'm going to use 34. I have 2 left. These 2 go on the central atom. So I'm going to move these now to the central atom like this. Couple of things. I kind of know the structure ahead of time a bit. Is that whenever I have something like this, these are going to go in an equatorial position. So actually, it's going to look something like this. I have chlorine. Yep. Fluorine here. Let me erase this. So you can look at your molecular geometry chart, and it says if you have 4 bonds and 1 pair of electrons, you have this type of shape. The pair of electrons go in the equatorial position. So they're in the equatorial position. So electron pairs take up more space than bonded electrons, so it goes to equatorial. So a couple of things. If you look at the geometry table I gave you, 4 bonds, 1 pair of electrons. This is actually a seesaw shape. So a seesaw geometry. This one, since it's got a pair of electrons on the central atom, it's seesaw. It's going to be polar. So those things are always going to be polar bonds.